Hi everyone, so I'm going to do some analysis on the incredible system Hurricane Ophelia. And this system is really quite remarkable um, because it's a tropical cyclone that is unusually far to the northeast of the Atlantic Ocean. So occasionally you do get these systems forming in the northeast Atlantic, but this is an unusually strong one, a category 2, which is quite strong for a system so far northeast. And they don't come around that often. So I'm going to do an analysis of this storm, particularly since you can see in the prediction cone that it's projected to hit Ireland, and I'll discuss the elements of the extratropical transition, whether or not actually the storm is going to hit Ireland as a tropical cyclone or whether it's going to transition into an extratropical cyclone. Although for the purposes of whether or not this system is going to do significant damage, it doesn't really matter that much. Either way, it's still probably going to be a very damaging system to residents of the Republic of Ireland. So I'll discuss that. So a bit of background first. So Hurricane Ophelia is the 10th consecutive hurricane in the 2017 Atlantic hurricane season. I think it must be something like the 15th named storm. I can't remember exactly. But it's a particularly unusual system because of where it formed. You can see here it's formed in the northeast Atlantic. So what happens sometimes is you get these extratropical cyclones, which are non-tropical systems. They derive their energy in a different way, that stagnate in sort of warm waters for a while, and they kind of spin up into tropical systems. And that's one way of getting tropical cyclogenesis. The more usual method of getting it is to have the tropical disturbance come across from the African continent, and the disturbance consists of significant arrangement of thunderstorms, and then the thunderstorm starts to have this spinner rotation, and it eventually turns into a tropical depression and so on. That's the usual mechanism. But you can also get this other mechanism where an extratropical cyclone, that's a non-tropical cyclone, forms over relatively warm waters and becomes one after stagnating for a few days. And that's what happened in the case of Hurricane Ophelia. So Ophelia intensified to a category 2 storm. It's slightly weaker now, but it was at its strongest wind speeds of 105 miles an hour, which is quite significant. And so it's a mid-level category 2, and I can actually play here some sort of satellite loops. So I'll just refresh this to get the most recent sort of satellite loops. This is the infrared imagery. You can see here Ophelia is actually struggling a little bit. You can see that it's not able to maintain a consistent eye wall structure. Certainly yesterday it seemed to be doing a lot better in terms of its satellite presentation. It had a more classically looking pinhole type eye structure, but at the moment it almost seems like it's undergoing some kind of structural rearrangement, or even something maybe that half looks like one of these eye wall replacement cycles. Of course, these small systems don't tend to undergo these classical processes of the eye wall replacement cycle, but it looks like it's trying to undergo some kind of structural rearrangement. So maybe we'll see a more coherent, maybe slightly bigger eye that develops out of this. The other alternative is that maybe wind shear is starting to affect the storm and weaken it slightly. But wind shear is actually quite low. So I kind of prefer the explanation that it's undergoing some kind of structural reorganization, because it only has weakened relatively slightly. So it's down about 5 miles an hour on where it was yesterday. So I honestly don't know, though. It also might be the case that the colder water might be affecting the tropical development, and that's another thing to take into account. But I've always tried to emphasize the misconceptions about tropical cyclones and cold water. So there's people like to talk about the 26.5 degrees Celsius requirement for tropical cyclogenesis, and that is true to some degree, but mostly only for the first type of tropical cyclones that I talked about, the type where you initially get this disturbance moving from Africa, and it's this tropical wave of thunderstorms, and it spins up into a tropical cyclone. And usually that only occurs with temperatures above about 26.5 degrees. But for the second type of tropical cyclones that originally start off as this extratropical cyclone that sort of stagnates and eventually obtains a warm core and spins up, that these high sea surface temperatures are not required, and they're not strictly necessary. One branch of systems I'm quite interested in is medicanes, which I actually did my master's thesis on. And these are like tropical systems that form in the Mediterranean, and they're quite a lot smaller, and they don't require warm sea surface temperatures. But anyway, the point I'm trying to make is that warm sea surface temperatures generally do definitely help. They certainly make the convection stronger. So this may also impact the system, but I want to get over the fact that warm sea surface temperatures are irreconcilable with tropical systems. It's more a case of it's advantageous to get them as warm as you possibly can do. So that these factors are all going to come into play, of course. So that's the current structure. I think one other thing we can quickly look at is this again gives I guess a more clear indication of the cloud top temperatures. So colder temperature surrounding the eye wall is better. It means that the convection is stronger, that the clouds are taller. And again, we've got this disorganized eye wall structure that seems trying to be developing itself. It's certainly not as good as it was yesterday, but in any case. So over the next few days, the system is going to, now this is this part that really interests me, the extratropical transition. So it's going to move northeast into colder waters, into waters with stronger wind shear, and it's going to interact with a trough that's sort of coming in from the northwest. So this trough is an area of low pressure. And behind this trough, there's quite cold air, and it's going to interact with that cold air and undergo what I'd call a baroclinic intensification. So essentially what that means is baroclinic intensification is the mechanism by which extratropical cyclones develop. So an extratropical cyclone, a cyclone outside the tropics, develops through baroclinic forces. And what that means is that the forces that govern the development of an extratropical cyclone are horizontal temperature gradients. So a normal extratropical cyclone will develop when you have cold polar air that comes into contact with warm tropical air, and it causes the warm tropical air to rise above the colder air, and then you get the low pressure that deepens through that. So that's an extratropical cyclone. Now, tropical cyclones don't behave like that. They don't need these horizontal temperature gradients. In fact, actually, horizontal temperature gradients are generally bad news for tropical cyclones. Tropical cyclones rely on vertical temperature gradients. So they rely on colder air in the upper atmosphere, warmer air towards the surface, and that's why you generally need these warmer sea surface temperatures to get this strong vertical instability. So that's essentially the crude difference between extratropical and tropical. Tropical is more about vertical instability. Extratropical is more about horizontal instability. So the transition is what's going to happen is that this tropical cyclone is going to move northeast. It's going to move into colder water. It's going to move into higher wind shear. That means that the wind varies with height. Again, this is not good at all for tropical cyclones, and it's going to come into contact with colder air by interacting with this trough from the northwest. So the interaction with the colder air is going to result in a transition from tropical, which is a system that relies on the vertical instability, to extratropical, which is a system that relies on the horizontal instability. So that process will occur over maybe 24, 48 hours. And it's also, incidentally, a process that was significantly prolonged in the case of Hurricane Sandy. So Hurricane Sandy had this unusually long extratropical transition process where it stayed as this kind of hybrid system with both tropical and extratropical characteristics for a long period of time. And that was part of the reason it was so problematic. It had characteristics of both systems. So we're going to see that in the case of Ophelia, and actually Ophelia might be analogous in many ways to Hurricane Sandy. I'll come back to that later. Now, the point I really want to touch on at this point is whether or not this storm can get to the UK or Ireland, any part of British Isles really, while still remaining tropical. So I guess the question I'm asking is, can the extratropical transition last long enough such that the tropical cyclone still has tropical characteristics when it hits the British Isles? And that's very important meteorologically, less important if we're talking about the practical implications of Hurricane Ophelia. But meteorologically, it's important because a hurricane has never landfalled, with the possible exception of Debbie, which I'll talk about in a sec, on the British Isles before. So we would be making meteorological history essentially if this were to happen. And indeed, the NHC forecast suggests that it's going to be tropical. At least it's going to have some tropical characteristics, which means that the transition is still going to be underway up until sort of around here. So it's to the northwest of Spain. At this kind of point, sort of early on Monday morning, late on Sunday night, there's still going to be tropical characteristics. So it'll still be a hurricane, essentially. Now, whether or not it can actually get all the way over here while still being a hurricane, as opposed to simply an extratropical system with hurricane force winds, is a different question, maybe less likely. Nevertheless, even if it manages to get somewhere over here, I think that would be the furthest northeast a hurricane has ever managed to get. Certainly, I mean, certainly in the last 200 years. So, I mean, this system is already going to break records, meteorologically speaking. This is a remarkable system. But if it manages to maintain that slightly further and gets to Ireland as a tropical system, then what can I say? I mean, it'll be a once in a lifetime event. It'll be totally unprecedented. This has never happened before. So let's have a quick look at this extratropical transition then. So I've got here the Met Office analysis charts. So the Met Office is the British weather forecasting, the national weather forecasting company responsible for national forecasts, and they make these nice charts where you can have an analyzed look at the synoptic situation. So we can see this is sort of a nice chart for today at on Friday, and we can see we've got low pressure up here, high pressure down here. Again, this is all fairly mundane stuff. And then frontal systems. This is obviously an extratropical cyclone. It has fronts, which is typical of extratropical. Now, the point I really want to emphasize is if we go further on, we'll be able to see Ophelia coming in to the bottom here, and you can see it's given a different symbol. The Met Office have labeled it with the swirling tropical cyclone symbol. Now, it's actually very rare to see this symbol on these charts. So you occasionally see them right at the bottom, but it tends to be rare enough to actually get them on here. But look what happens now. So at 48 hours, this is still considered to be a tropical system. And now at the same time, I should emphasize that the extratropical transition has probably already begun at this point. You can see that this frontal system is starting to move closer, and there's cold air behind this. So we're already getting some kind of interaction. Nevertheless, the transition has not finished. So as long as the transition is not finished, this is still considered a hurricane. So that's at 48 hours. 60 hours. Now, at this point, the transition is nearly finished. But nevertheless, we can still see this symbol. And this is, without doubt, the closest to the United Kingdom I have ever seen effects chart show a hurricane. This is by far the closest. This has never happened before. The best example of one that maybe, I mean, I'll talk about a few examples, but Hurricane Vince, of course, was somewhere down here and eventually went on to hit Spain as a still completely tropical depression. So that was one example. And I'll also discuss Tropical Storm Grace. That's another interesting example as well. Now, if we go, so I think we're on 60 hours. If we go to 72, you can see that at this point, the label has changed. This is ex Ophelia, and we no longer get that swirling cloud symbol. So the transition is completed at this stage. But you can see it's pretty damn close to Ireland before it does so. So we're talking about still an unprecedented situation, but we don't have to. The forecast doesn't have to change much. It only has to stay tropical for a little bit longer to make meteorological history. Whether or not it can do that will depend on a few different things. It'll partly depend on exactly how far east Ophelia moves. I kind of feel that if Ophelia can move slightly further east, then the interaction with the trough will be less significant, and it'll take longer for the trough to sort of kill off all the tropical activity. But on the other hand, if it's further east, then it won't accelerate as fast either. So there's also that. So I'm honestly not sure, but we'll have to see. So I'm also going to quickly show you the latest GFS run. Again, this is just another one of the model runs. So this is a theta E value. Think of theta E as kind of a combination between temperature and moisture. So the reddish colors basically mean warm and moist. The blue and purples mean cold and dry. So kind of think of them as kind of a combination. So you can see the transition here really well. So you can see it's a hurricane here. The storm is so we've got no baroclinicity. Remember, I talked about baroclinicity being a gradient between warm and cold horizontal plane. I mean, it's also a gradient between dry and moist as well. So you can see the extratropical transition quite clearly because you don't see any significant horizontal temperature gradient. You see the hurricane is this very warm blob of warm moist air. That's what the hurricane looks like. Okay, so let's take ourselves through. So this is sort of current, but let's take ourselves through. So this is sort of tomorrow evening, and we can see it tomorrow evening. It's still this blob of tropical air. So still fully tropical, but you can see that there's this cold front with colder air that's coming in behind. So we're starting to get this interaction that's starting to happen. So at the moment it's fully tropical, but there are forces that want to limit that. So let's keep going. So let's go sort of to Sunday. Now you see at this point, I still think it's tropical, but you can see that there's quite a significant gradient here between colder air and warmer air. So you can definitely see that the transition has begun. We've started to get this these baroclinic effects come into place, and the baroclinic effects in a sort of bizarre way are actually helping the storm intensify even further, in the same way that Sandy did. So Sandy had this sort of secondary maximum where it became stronger again due to the baroclinic effects sort of amplifying. So what Sandy was able to do is it was able to extract energy from both the vertical and the horizontal instability. So that's why it was called a hybrid. So during this period, it had attributes of both, but it was still classified as a hurricane because it still hadn't completed that transition. So as long as the transition is still underway, we would still call this a hurricane. This is more like a Sandy-like type system now. We've got this cold air coming in behind, but the circulation is still within the warm air. So it's still tropical at this point to all intents and purposes. So let's go a bit further. So now we're sort of so this is Sunday evening, and again, at Sunday evening, I would still say that's completely tropical because it's still within this sort of, the whole circulation is still within this very warm bubble, even though it's being sheared. Sheared basically means that the wind speed changes as you go up. We've got this shearing effect from the northwest where colder air is pummeling the cyclone, but it's still the whole circulation is still in the warm area at 48. But then look what happens at 54 hours. You can see that the cold air sort of completely overtakes the system, and we get the warm air sort of pinched off in sort of this warm sector of air to the east. This is incidentally going to bring really warm conditions to the UK. So according to the GFS, the tropical transition kind of completes before this thing manages to get to the UK. Although having said that, you can see that the center of this storm is still very warm. I mean, that's called a warm seclusion, which is something that you occasionally see in very strong extratropical cyclones during the mature stages. But in this case, this will still contain tropical air, so it might even still have the remnants of an eye wall kind of circulating in this system, but it will probably be declared extratropical at this point. Nevertheless, you can see that it's still getting to sort of France type latitude and still tropical at this point. It would be a hybrid system in the sense it would be deriving energy from both processes, but it would still be officially classified as a hurricane. So the point I'm trying to emphasize here is that we're really not far off. I'm simply talking about whether or not this system is going to officially be classified as a hurricane when it hits the UK. This is something that could potentially happen if the forecast gets adjusted. If this can maybe move a little bit faster, or if it's slightly further to the east. Anyway, I'll just have a brief look at some of the impacts, because to be honest, whether or not this transitions in where it transitions is not really going to matter, because it's still going to be a strong storm in any case. So I mean, Ireland is still going to be impacted by these very strong winds. So if we have that's something I'm going to discuss in a sec. If we have a quick look at sorry, here we go. If we have a quick look at the forecast path, we can see that you can see this is a white circle, because again, the wind strength is projected to be hurricane strength. It's just whether or not this system is characterized as tropical or extratropical. So that's why this is white. It says post/potential. So the NOAA has sort of implied that it could be post, and they're probably going to go with that. But it could also be tropical. But the reason that this is H basically means that the wind speed is still going to be hurricane force. So regardless of whether the system is tropical or whether it's extratropical, it's still going to have hurricane force winds. So it's either two possibilities. It's either going to be a hurricane, at which I would probably rate at about 25%, 30% when it actually hits Ireland, or it's going to be an extratropical storm with hurricane force winds, which I'd probably rate as the other 70%. Now, actually, I do think this is probably an over-exaggeration. I don't think, I know it says it's going to be hurricane, but I probably think it's going to be I still think there's a genuine possibility it could only be tropical storm type force. So instead of seeing 70 mile an hour sustained, 75 mile an hour sustained wind, and I think it will be 75 miles an hour. It's not going to be a strong category 1 if it is going to be a hurricane. We might be seeing 60, 70 mile an hour sustained wind speeds instead. But regardless, it's still going to be a really, really strong storm. Whether or not it's tropical, whether or not it's extratropical, whether it's tropical storm, whether it's hurricane extratropical, whether it's simply tropical storm strength extratropical, or they wouldn't really call it that. Regardless of what the hell it is, it's still going to be a strong storm. And actually, the extratropical transition poses another problem because when the extratropical transition completes, the wind field expands. So if it was to landfall as a hurricane, what you would expect to see is that the landfall would reduce the intensity a lot faster because a hurricane has to rely on latent heat fluxes from the ocean. So if this was to landfall as a hurricane, you would expect it to die very quickly once it hits land, and you'd also expect the wind field to be quite small. So the devastation would probably be more significant, but it would be limited to a much smaller area. Whereas if this landfalls as an extratropical cyclone, you'd expect a much larger area to be affected, and the effect of landfalling would weaken it to some degree, but probably not that much. So if anything, actually, if this landfalls as an extratropical cyclone, it will probably actually be more damaging than if it landfalls as a tropical cyclone, even though, I mean, I've suggested the latter is quite unlikely. But so regardless of the way that you think about this, it's still going to be a strong storm. A lot of people have compared it to the October 1987 storm, which is actually somewhat ironically a 30-year anniversary of that storm. Now, the October 1987 storm was a pure baroclinic system. This is something I want to emphasize. It was not tropical. It was not tropically derived. It did not start off as a hurricane. That was pure baroclinic effects. It was quite. It was. I mean, actually, I can get an archive of this. People might appreciate. So here we go. Archive. I think we're talking about 16th of October 1987. So I'll just briefly bring that up. Okay, so yeah, I'll go back a little bit so we can see how this develops. Okay, so you can see that the storm initially developed in this sort of large trough-like feature here. You can see that these are sort of 850 millibar lines. So that's basically the jet stream in a sense. This gradient here. Essentially, this developed out of a very strong jet. You had sort of air coming out of here, so sort of divergent air here. So it deepened at the top of the storm, and then it became stronger at the surface. But the point I'm trying to make is that this was purely extratropical. There was no tropical interaction whatsoever. It was I mean, you can see on the temperature gradient how significant the temperature gradients are. Very warm air here, very cold air here. This is about as pure baroclinic system you can get. So in terms of the thermodynamic structure of these systems, they couldn't actually be more different. They both obviously are going to be quite, well, we don't know exactly how impactful, but they're both going to be quite impactful. But the 1987 storm was purely baroclinic, so they had very, very different structure to an hurricane that's sort of in its extratropical transition. So they're very different systems, despite the fact that they have superficially similar wind strengths. So that's also something I wanted to point out. Have I covered everything? Okay, another thing I'm going to cover regarding the extratropical transition. Now you can view this thread. It's on the Weather Outlook forum. I'll post a link to this thread. But this quite ironically, about a month ago, you can see I posted this on the 12th of September, I actually did a bit of research into exactly how close tropical cyclones could get to the Europe. So how fortuitously I'd actually done the reading before this system turned up. So I kind of the gist of this is that in order to get a hurricane to hit the British Isles, you have to fulfill two criteria. One of which they've got to be hurricane force winds, and one of which the storm has to be barotropic. And when I say barotropic, I basically mean it has these tropical characteristics, it has this vertical instability, and so on that I've talked about. And you can kind of sum this up by saying it's got a warm core, so there's warm air situated in the center of the storm, as opposed to cold air. The storm actually gets weaker as you go up into the atmosphere, stronger at the surface, and it's symmetrical. Extratropical storms are not symmetrical. I mean, you could see that this 1987 thing, not symmetrical in the slightest, whereas a hurricane is obviously circular. So those are the criteria. So I looked at a few past cases, and there are some interesting ones. So Hurricane Debbie is now this is arguably the only other case where something like this has happened. So hurricane, and I want to draw a distinction between ex-hurricane and hurricane, or ex-tropical storm and tropical storm, because people in the media have talked a lot about ex-tropical storm Bertha, ex-tropical storm tropical cyclone Katia, and so on. These systems were definitely ex-tropical when they hit. The transition had long since finished. There was no hint of a tropical nature in these systems. I'm more interested in systems that still, even if they've undergone their tropical transition, even if they're still ex-tropical, they've at least done it relatively recently, and maybe they still have some tropical characteristics remaining. So these are the systems that I'm interested in, not ones that used to be hurricanes but are definitely clearly not now, even if they still have hurricane force winds. Now, Hurricane Debbie is the only other example of a tropical cyclone that actually, I say other, making the assumption that this one is going to do that. Clearly that's a bad assumption. But Hurricane Debbie is the only example of a hurricane that might have actually hit the British Isles while still being a tropical system. And you can see here, I mean, actually, it's this is. I mean, I can try and zoom in. Okay, here you can see here that we've got these circles. Circle implies tropical. The colours represent the strength. So you can see that this pale yellow means category 1 strength. Triangle means extratropical. So you can see that circle means tropical, triangle extratropical. And you can see that the transition basically occurs over Ireland. Or should I say the transition finished occurring over Ireland? It probably was occurring, or the transition probably started somewhere around here. So Hurricane Debbie was an example of one that, at the very least, had relatively recently undergone the transition, and this was a very devastating storm. This caused a lot of damage to Northern Ireland. Nevertheless, it's an interesting example of a storm that managed to get that far north, east, without transitioning, or at least without finishing transition. So this is maybe the only other example that we have a precedent for. So that's that one. Then we have Hurricane Faith. Which, if you would believe, and I'm not, it's the problem with this, of course, is that this all happened kind of before the reliable satellite records. So I'm not exactly sure how reliable these older systems are with regards to whether it's tropical, whether it's not tropical. So I'm going to take this with a little bit of salt. But Hurricane Faith apparently finished its extratropical transition near the Faroe Islands, which is truly remarkable. And the reason that it did that, I think, was because it was such a big hurricane, and it was moving so fast that the principle is that it still takes a while to kill it. So all the factors were against it while it was in the North Atlantic, but you still had to actually kill the damn thing, and it still takes a while to kill it. So I think it was mostly because it was big and moving fast, rather than a particularly good environmental conditions. Now we're getting into more interesting territory. Hurricane Vince is unambiguous because this was definitely tropical. No dispute about, no ambiguity about this at all. So this developed quite similar to Ophelia as one of these extratropical cyclones that sort of span around for a bit and developed this warm core, and eventually sort of became a hurricane. You can see this yellow circle that implies hurricane strength. But all these are circles, which still means that they're tropical systems. So eventually, this didn't hit Spain as a hurricane, but it did hit Spain as a tropical depression. It's still as impressive. It just means that it didn't actually have hurricane force winds, but it was still a tropical system. So that's, to me, that's still basically as impressive. So this is basically the only undisputed case of a tropical cyclone ever hitting Europe. So when people say that tropical cyclones cannot hit Europe, this is basically the proof that they can. And this is not like Debbie, this is not like Faith. This definitely happened. This is definitely an example of a tropical cyclone hitting Europe. So this is the undisputed case, essentially. We have a few others. So again, I'll skip over that one because I don't know too much about it. But Tropical Storm Grace is one I want to mention as well. I mentioned it a little bit earlier in the video. Tropical Storm Grace is interesting because it formed in waters that were unusually cold. I think about 18 or 19 degrees. And again, that is still possible if you get a lot of cold air in the upper troposphere. So these sea surface temperatures are desirable, particularly for storms that form in the conventional sort of African wave way, but they're not essential. So this is not an irreconcilable situation. But Tropical Storm Grace is an example I want to draw attention to because this is another undisputed case. It happened relatively recently. So if we're talking about something that happens from the late 90s onwards, that this is going to be reliable. Tropical Storm Grace, look how close it got. I mean, you can see that there's a circle here. It's northern France. It's like the same latitude as Cornwall. I mean, this is undisputedly the closest that a tropical cyclone has ever got to the UK. And look how bloody close it got. So people that say that tropical cyclones cannot get close to the UK, well, this Tropical Storm Grace kind of proves that they can. Look how close. I mean, obviously, this is ridiculously rare. I mean, this is one example, and this is the only example that we have of this kind of thing happening. But nevertheless, you only need one example to prove a point. So it underwent its extratropical transition, and its extratropical transition was very undramatic. So we didn't see this interaction with a trough. We didn't see this rapid deepening due to bad cooling effects. No. This thing transitioned in. This thing died simply because it was too cold. I mean, there are limits. So at this point, the water was about 15 degrees. And even at this point, the system just couldn't continue any further. So it just sort of fizzled out in a sense. So this one went by ice, not by fire. Ophelia was going to go by fire. But this one went by ice. But nevertheless, look how close it got. And this thing actually had an eye wall as well. It had a definite eye wall structure. So Tropical Storm Grace is I think one of the more interesting ones, even though it never got to hurricane strength, and it nearly got to hurricane strength. But this one is good because it simply got so close to the British Isles. So yeah, so that's just a few things I wanted to draw attention to with regards to past precedents for this sort of thing. What else? Okay, heart phase spaces. I'll quickly touch on that. Okay, so what I've got here is a heart phase space diagram, and these are quite nice because they allow you to identify what kind of storm you're looking at. So I've talked about the characteristics of a tropical storm cyclone. It's got a warm core. That means that there's warm air towards its center. There's no steep horizontal temperature gradients. So this essentially boils down to it's symmetric and it's warm near the middle. Okay, so Hart had this bright idea where he would use these parameters to identify whether a storm is tropical or atropical and so on. He came up with a system where you can plot on one axis how warm the core of the storm is, whether it's warm core or cold core, and whether it's symmetrical or asymmetric. So hurricanes have this property where they're warm cored and they're symmetric. So anything in this kind of area, in this red zone, is a hurricane. Well, not necessarily a hurricane, but a tropical type system. So you can see actually where we are now, where the sea is. That's where Hurricane Ophelia is now, and we can see that sea is here. So we can see that we're in the warm core type system, and you can see that we stay in this region up until around here, and then we start to move into this asymmetric warm core area, this pink area. So that signals the point at which the transition has begun, in my opinion. So what we start to see is the storm still has a warm core, but it's becoming less symmetric, and that's again because of this interaction with this trough that introduces some cold air to the northwest, and we start to see this baroclinic intensification starting to occur. So the storm is gradually becoming sort of more extratropical. But you can see that it takes a while for the storm to actually complete the process and become a fully asymmetric cold core extratropical cyclone. Now, exactly when this transition is completed, again, I mean, you can't really necessarily tell from these phase-space diagrams, and this one actually just has looks at again. This is a deep warm core. This is a deep cold core, but you can see that the transition does kind of begin over here, and then it gradually transitions to extratropical cyclone. Now, I want you to keep this in mind because I'm going to compare this to another storm that you might know quite well, which is, if I can get the archive historic diagrams, here we go. Hurricane Sandy, of course, which is here. Okay, so this is Hurricane Sandy. Can I get one that's actually looks vaguely similar? Oh no, I can't. They look slightly different, but I hope you can get the gist of it. That with Hurricane Sandy, the point I'm trying to make is that they look quite similar. That's the point I'm trying to make. We start off with this symmetric warm core. We spend a bit of time in this asymmetric warm core phase, and then we end up in this asymmetric cold core phase. And you can see that we move into this what was pink in the other diagram at about 27. It was still considered to be a hurricane up until around here. So up until sort of this point, it was still considered to be a hurricane. So you can compare that with Ophelia, kind of imply that somewhere around here, maybe it finishes its transition. So I mean, the point I think I can be justified in making the comparison between Sandy and tropical cyclone Hurricane Ophelia, because they're both similar systems. They're both systems that were fully tropical, that interacted with an extratropical cyclone and became this kind of hybrid mess of both characteristics. So this is what I think we're going to see. Okay, I'm quite tired now after all that. I might do another one of these tomorrow night when we know a little bit more. Apparently some people watched it, so I thank people for doing that. I'm just seeing if anyone's left a comment. Thanks everyone who watched it. I appreciate that. So I'll probably do another one of these tomorrow night, and I hope everyone enjoyed. Thanks.